and x plus 2y equals 7. Now you guys already know how to solve these problems using substitution and elimination. But today we're going to learn how to solve these problems. Okay guys, today what we're going to look at is the gradient or the slope of a line passing through 2 points. Now, if you recall the definition of a slope, usually we define that with an m, but the slope or the gradient is the change in the y-coordinate divided by the change in the x-coordinate. So oftentimes we write it as y2 minus y1 over x2 minus x1. And we'll just do a quick example. Find the slope of the line passing through A, which is at 2, 3, and B, which is at 3, 6. So A is at 2, 3, B is at 3, 6. Let's set A as our x1, y1, and let's set B as our x2, y2. Okay? So y2 minus y1 is going to be 6 minus 3, and our x2 minus x1 is going to be 3 minus 2. So overall, our slope in this case is going to be 3 over 1, which is equal to 3. Okay? Now a quick reminder on what the definition of different types of slopes are. Okay, if we have a line going this way, diagonally upward, this is what we would call a positive slope. Positive m, right? Because we're going up. Right? We're going up the mountain. Right? Think of this one as going down the mountain, right? We're going downwards, so this must be a negative m. Okay? Negative slope. Now a couple of special cases. I'm not sure if you guys remember, but if we have a horizontal line, we consider this as n equals 0. Okay, the slope is 0. It's not going up, it's not going down, it's just flat. So slope is 0. Okay? And then finally, if you have a vertical line like this, basically we say it's an undefined slope. Okay, so a quick review of the different types of slopes and what they tell us about the shape of the line. Okay guys, so for our next example, we'll do the same thing. Find the slope of the line passing through the points 2, 1, and negative 1, 4. Now what I want to do for this example is sort of illustrate on the graph what it looks like. And if we plot these 2 points, okay, 2, 1 is right here, over 2, up 1. So that's this point right here. And over here we have negative 1, 4. Plot this over here. Down 1, up 4. We can see that the line has a downward motion, right? So a downward slope, meaning this m is negative, right? The slope of this line, or the gradient of this line, must be negative. And of course we can check that by calculating, right? So let's set this as our x1, y1. We'll set this to be our x2, y2. So we'll say y2 is 4 minus 1 over x2 is negative 1 minus 2. And as you can see, 4 minus 1 is 3. Negative 1 minus 2 is negative 3, so the whole thing comes out to be negative 1. Right? Negative slope, negative slope. Now, the other thing is, it doesn't matter which coordinate we choose to be our 1s and our 2s, as long as we're consistent. So we can say this can be our x2, y2. They both have to be 2s. This one can be our x1, y1. These both have to be 1s. And if we flip the numbers, we'll still get the same slope. So, quick check. Oops, sorry. Quick check. 1 minus 4 on the top. 2 minus negative 1. 2 minus negative 1 on the bottom. Top is negative 3. Bottom is positive 3, which still ends up with negative 1. So no matter which coordinate we pick as our 1 and our 2, As long as we're consistent, we will still end up with the same slope. All right, guys, last example. This one's tricky. Given distinct points, distinct meaning not the same, these are three different points. Given distinct points A, B, and C, A being T1, B being 2, 4, and C is 1T, these are collinear. Find the value of T. Now, the word collinear just means on the same line. On the same line. So, if I were to draw this on a graph, it would look like this, right? I have C at 1T, B somewhere to the right because it's got an x-coordinate of 2, so B must be somewhere to the right at 2, 4, and A must be probably somewhere farther down at T, 1. They're all along the same line. And what we want to do is we want to find the value of T. So in order to find the value of T, we have to take advantage of the principle slope of a line passing through 2 points. And what we know is that the slope from B to C has to equal the slope from A to B. Right? The slope from here to here is the same as the slope from here to here. So if I create an equation to map that, hopefully I can solve for T. Let's take a look. Let's calculate the slope from B to C. All right, let's call this our 2 and this our 1. So 4 minus T on top. And on the bottom, 2 minus 1. 2 minus 1. That's my slope of B to C. Right? That should be equal to my slope from A to B. So let's call this our 2 and this our 1. So 1 minus 4 on the top, T minus 2 on the bottom. Okay? Now we're going to have to simplify this and do a little bit of algebra. So from here, 4 minus T over 1 equals negative 3 over T minus 2. Multiply this guy up here. 4 minus T times T minus 2 equals negative 3. Okay, we're going to have to FOIL this out. Let's do it over here. 4T minus T squared plus 2T T equals 5 and T equals 1. Almost there. We wanted to find the value of T. We got 2 T's. All right, but we got to do a quick check. If I plug in T equals 1 into these 2 T's, what do I get? Well, A would be 1, 1. Right? And C would also be 1, 1. Got to read the question carefully. The question says distinct. Distinct means not the same point, right? So we cannot use T equals 1 because then we would end up with the same points, and that's not what the question says. So the only answer we can use is T equals 1. Okay, guys, practice problems. A couple of problems. Find the slope or gradient of these 2 lines. Okay, I'll see you guys tomorrow.